Good morning. Well, it's afternoon here, but my body still thinks it's morning, so I'm still working on the time shift from upstate New York. Again, my name is Brian Becker, and I'm with Blue Dolphin Solutions. It's a consultancy I've maintained since 1983, and today we're going to talk about APL and Web Services. If you think that this is the dialogue vendor session, it's not. And so if you're not here to talk about APL and Web Services, you're welcome to stick around. Otherwise, why don't we go ahead and get started. I thought we'd go over the objectives for today's workshop, and I'll share my objectives first, and then if you have any that are in addition or contrary to mine, please feel free to share them with me. One is I want to introduce some basic concepts about web services. And what are they? What are they used for, and why should we care? Then I want to demonstrate this standalone web service framework. We call it SAWS. One thing I want to point out is if I'm speaking too quickly for anybody, or if I'm not articulating well enough, please let me know so I can either slow down or try and make accommodations so that I can be understood, if that's possible. Then we're going to teach you SAWS, and you're actually going to be able to build a web service today on your own laptops if you have a laptop, and we're going to try and do all this within 2 hours. Does anybody here have any other objectives that they'd like to put forth? Good. Then we're in agreement. So by the end of the workshop, you should have a basic understanding of what web services are, be able to use third-party web services from APL, and be able to write an APL-based web service. And we're going to do that all within 2 hours. So I wanted to talk about some of the challenges that seem to be apparent today. One is there's quite a bit of APL-based functionality that's in legacy systems and that people have developed that's largely unavailable for use outside of APL. And that's traditionally been a problem with APL. Now, there are a lot of things that have been done over the years with .NET interfacing and other technologies to make APL play well with the other kids in the sandbox. But still, there's a lot of legacy code out there that, by and large, is not available outside of the APL environment. And there's quite a bit more non-APL based functionality and data that's largely unavailable for use within APL. And so one of the things that we'd like to be able to do is to use data and functionality that's outside of APL in our APL applications and share things that we've developed in APL with the rest of the world. And the other thing that's an observation, I know this is certainly true in my case, is that APLers are generally better at solving problems than they are at designing user interfaces. If you've seen some of my applications, you'd probably agree wholeheartedly with me. So what are web services? How many people here have used a web service? Raise your hands. Okay, everybody should raise their hand. How many people have ever been on the internet? Please, everybody raise your hand. If you've used Google or MapQuest or any of the mapping software or any of those things, those are all web services. And so we've all used them, though we may not have realized that that's actually what we're doing. So what are web services? Web services are automated information services that are conducted over the internet using standardized technologies and formats and protocols that simplify the exchange and integration of large amounts of data over the internet. So what's that? There are a few key words in here. One is they're automated information services. So you invoke a web service and you get something back. There's it can have two processes that are automated to do that data exchange. They use standardized technology, so there are standards out there that you adhere to when you're using web services, and everybody plays by the same standards. So it doesn't matter whether your web service is written in APL or C# or Java or whatever. And so they make it easier to conduct work across organizations regardless of the types of operating systems, the hardware, software, the programming languages, or the databases that are being used. So this is a nice way, you know, again, if one of the things that we want to do is to provide access to our APL functionality and data, or to get access to somebody else's data and functionality, if we use these standards, it's easier to do that interchange. So let's talk about the anatomy of a web service. Typically, you'll have a service requester and a service provider. That's these two blue ovals. And the service requester is going to be running some sort of client software. In some cases, it might be as simple as an internet browser. Internet Explorer, Safari, Opera, Mozilla, any of those. Or it could be a customized client. The service provider has a service, a web service that's running, and this web service is described using WSDL, which stands for Web Service Description Language. So the client over here sends an XML SOAP request. So we'll get into what that means, but it's based on this web service description. The provider gets the request, does something with it, and sends back a response that's based on that web service description. So again, if anybody has any questions as we're going through this, please feel free to ask. Okay, so SOAP, originally it stood for Simple Object Access Protocol. Now SOAP stands for SOAP. It's kind of like, anybody here, I used to work at STSC. It used to stand for Scientific Time Sharing Corporation. Then it just stood for STSC. So SOAP stands for nothing now. But SOAP is XML-based. And so here's a bit of a SOAP message, web service message that's just an XML message. And you can see there's a lot of stuff going on in there. Then there's WSDL, which is the Web Service Description Language. So this is how we describe our web service to the rest of the world. And it's also XML based, and it's pretty god-awful. You know, it's lengthy and cumbersome, and you really don't want to write that by hand. So this is why we have SAWS, the Standalone Web Service Framework. Standalone means that it doesn't require Microsoft IIS, it doesn't require Apache, IBM WebSphere, or any other server software. SAWS has got a built-in server, so all you need is an open port and network connectivity to run a web service. It's a web service, so it uses those standard protocols and formats. It uses XML, it uses HTTP for its, to communicate back and forth, or HTTPS if you're doing secure communications. It uses SOAP 1.1, which is one of the standards, and WSDL. But the nice thing is that you don't have to know about these technologies, these protocols, you don't have to learn them to use SAWS. Now, I put the much in there because having an understanding of them will help you in developing, in consuming other web services and in providing your own, but you don't have to get into all of the intricacies of SOAP and WSDL to make SAWS work. Did you have a question, Kai? Okay. And SAWS uses Conga underneath for its TCP/IP communications over HTTP and HTTPS. Conga is the dialog replacement for the TCP socket object that makes it a lot simpler, I mean infinitely simpler, to communicate using TCP/IP between APL and anything else that talks TCP/IP. And we can thank Bjorn here for a lot of what Conga does. So, or blame him for a lot of what it does, either way. So what are some of the benefits of SAWS? One is you can use third-party web services. And it also gives access to your legacy APL applications. You can also build new service-oriented applications using SAWS. And it's platform independent. It basically runs any place Dialog 12.1 runs. So it runs under Windows, it runs under Linux, it runs under AIX. We have, there's some people that I've been working with are using it under AIX. I have it running on between a Linux virtual machine and my Windows system on my platform here. So you can, wherever Dialog 12.1 runs, SAWS runs, and Conga runs. So this kind of helps level the playing field. In some cases where management might be reluctant to use APL to provide functionality, here we've leveled the playing field. We've made it easier for the rest of the world to get to our APL applications and our data. So we can spend our time solving problems, doing the things that we as APLers do well, and make it easy to get to that data and that functionality. Okay, one of the things is, for those of you that do have Dialog APL already installed, on your the memory stick that you got with your conference materials, there's a SAWS subdirectory on that memory stick, and the SAWS workspace is in that directory. So load that or copy it or do something useful with it. Okay. So what I've done here is I've loaded a version of the SAWS workspace, and I have one of the utilities that comes as a user command, and Dan Baronet is going to be talking about user commands, I think, tomorrow. But there's a way that you can write a script for a demo, and so this is what I've loaded up my SAWS demo script. But the first thing that you want that gets done is this SAWS init, and that just initializes SAWS. It loads Conga and initializes a couple of global variables and so on. So we're going to go out and take a look at a web service that's out on the internet. And the URL here, if you can everybody read that? If not, I have chalk. It's ws.cdine.com/weather ws/weather.smx. So this is a web service that's offered by a company called cdine, and they offer a number of different web services that you can subscribe to. This happens to be one of their free ones that's available on their website. And what you can do is you can look at, for instance, get city weather by zip. So this will retrieve the weather, the current weather, for a zip code in the United States. And I apologize that this is a United States oriented website. The more global weather service that I normally use to demonstrate, for some reason I can't get to from here, so we'll use this, but it's pretty much the same. So my home zip code is 14586, and it returns some XML here, and it says here that the request was successful, that it found the city, that it's in New York, the city name is West Henrietta, the weather station city is Rochester. This weather ID is 9, and we'll go into what that means in a little bit. It's partly sunny in Rochester right now. The temperature is 63 Fahrenheit. The relative humidity is 62%. The winds are out of the north at 7 miles per hour, gusting to 17 miles per hour. And the barometric pressure is 30.02 and steady. So this is a web service that's now retrieved a bunch of information that we could use from APL. Now, one of the things that we remember, there was this weather ID here is 9, And they offer another web service called Get Weather Information, which tells you what each of those weather IDs means. So weather ID 1 is there's thunderstorms, and 9 in this case means that it's partly sunny. So there are a couple of things here to look at. One is, let's go back to the Get Weather by Zip. A lot of web services will publish sample requests for what a typical request and response will look like. And this is the SOAP request on how to request this particular method in this web service. And this is the SOAP response that you can expect back. Now sometimes a web service will publish more than one protocol. In this case it has both SOAP 1.1 and SOAP 1.2. And also HTTP GET and HTTP POST. So there are different ways that you can grab, different protocols you can use to invoke web services. Okay. So let's go and get that same information here, Get Weather by Zip. And what I did was I used a function called saws.call. Now, how many people are familiar with namespaces under Dialog APL? How many people are not, actually more importantly, how many people are not familiar with namespaces under Dialog APL? Good. Then I don't need to explain what namespaces are. But this runs a function called call, and what it does is it takes a URL, a port number, where the service page is located, the service name, the method name, which is Get City Weather by Zip, and then some parameters. And in this case, the parameter is called zip, and it takes a string, which is the zip code. So if we were to go back to our SOAP definition here, you can see here in the SOAP definition that it takes a thing called zip. Well, the function name here is Get City Weather by Zip, and it takes an argument called zip, and it's a string. So we were able to specify that in APL and get this result back. And the result that you get from saws, if the execution of the call was successful, you get a 0 return code. Otherwise, you'd get a non-zero return code that would mean something about why it didn't work. And you get the method name that you invoked, the result of the method, and then some other stuff. And if we take a look at, let's assign that result to W, and we'll take a look at, if we take a look at the shape of W, it's 2, if we display W, is everybody familiar with, yes? 80 is the port number. Yeah, and typically for an HTTP connection, port 80 is typically used for HTTP, and 443 is used for HTTPS. If you don't specify it, if you don't specify a protocol in the URL, and you don't specify the port, it'll default to 80. If you specify a protocol, it will look whether it's HTTP or HTTPS and assign 80 or 443 as appropriate. So the first thing in W is the return code, and the second thing is this nested array. And the thing that's of particular interest is, yes? Sure. Oh, okay. So if I take a look at the 2.2 pick of W, this is the data that was returned by the web service. And this is a structure that's known within SAWS as an MLS, which is a markup language structure. It's very similar to something that we'll be looking at shortly called, it's the result of Quad XML. And yes, go up again. You don't necessarily need to be typing along for this part.
No, but it seems to have to make sure it's working.
Oh, absolutely, sure. Actually, if you want to test if SAWS is working, you can do /SAWS dot, I think it's test. Oop. And it'll run a little thing against, it brings up its own little web service. So this is a good way to test if SAWS is working. Just do a SAWS test 1, and it will fire up SAWS, a thread that runs a SAWS server, and then call its own service 100 times and tell you that it, well, we ran 100 calls in, 2,200 milliseconds, so we basically executed 45 calls a second on a little regression workspace, or a service. Yes? Yeah, on your memory stick that you got in your conference packet, there's a SAWS directory on that memory stick, and the workspace is in there.
Is the 12-1 interpreter on that?
What's that?
Is the 12-1 interpreter on the USB?
No, but we have it available on USB here for you to install. And don't worry if you don't have it installed yet. You can work on getting it installed as we go through the demonstration, and in a little bit then you'll actually want to be doing some hands-on stuff. So there's the results of the get weather by zip, get city weather by zip function. Now there's also another web service that's offered by the United States government at www.weather.gov, and it's a little more complex. What you do is you give it a zip code list, and it returns a list of latitudes and longitudes that you can then use to call a web service to get the weather for that particular location. So in this case, I'm looking at the latitude and longitude for my home in Henrietta, New York. And so the XML that it produced. Now notice that the web service from CDYNE returned something that's relatively useful here. It's an APL, SAWS.call knew how to interpret that, and it returned it as a matrix that you can then work with directly in APL. The web service from the United States government returned an XML string. And if you look at the workspace description language from the United States government website, you'll see that the description of the result says it's a string. So I was able to pull out here I use Quad XML. How many people are familiar with Quad XML? How many people are not familiar with Quad XML? Okay. Quad XML is, I don't remember which version of Dialog it was released, I think 12.1. And it's a really nice system function to work with XML data. And it works two ways. One is it will take an XML string and convert it into an APL matrix that you can then work with in a way that's familiar and to APLers. The other thing that you can do is you can take an APL matrix and pass it to Quad XML, and then it produces the XML string. So this is a really terrific way of taking APL data and putting it in a format that is virtually ubiquitous. I mean, it's everywhere, right? So in this case, I took the XML string, which is the that I got back from the US government website. And the one thing that I care about here is this lat long list, which is 43 point whatever and negative 77 degrees. That's the latitude and longitude of my hometown. So now I can take that latitude and longitude, and I can call the US government web service, port 80, where the web service is located, and I can give it that latitude and longitude. And then if you look at their workspace description or their web service description, there are a number of parameters that you can pass. In this case, I want to take a glance at what the weather is, and I want it to be from today at noon to today at 1800. And you get back a whole lot of XML. And I assigned the result there to ZZ, and we can take a look at what ZZ is. And so you can see here that it's actually got some HTML in there that you could throw up as a web page. You could view this in a browser. But it talks about a few different things. One is it has different designations for the time slices that this particular web surface keeps track of different types of weather. So here's one that looks at the weather every 3 hours. This is hourly. There's one that's just a single time frame. But it says that the daily maximum temperature today is going to be 72 degrees. That at 2, 5, and 8 p.m., the cloud cover is going to be 54%, 49%, and 39%, which for Rochester is pretty sunny. I don't know if you've ever been to upstate New York, but we don't see the sun very often there. And so there's a whole lot of information here. And you can use Quad XML to extract this information, manipulate it, and use it in APL. You could use it to produce your own web service. So it's fairly common for web services you may develop to use other web services to get data and present it or use it in different ways. Okay, now we're going to take a quick look at one of the web services that's provided with SAWS, and it's called Price Check. And this is a simple database-driven web service. And our database is really sophisticated here. In this case, it's just an APL matrix. And it's got 3 columns. The first column is a product name, the second column is a quantity on hand, and the third column is a price. So you can see that balls are pretty expensive in this particular application. And cactuses we're out of, so. But then there are a couple of other things. One, the way that you build a web service, and let me flip back to my, okay. So we're going to look into the Price Check web service here. We're going to run this web service in another thread in our workspace. Now there are a few things that a web service that you build needs to have. One is this function called build API. And what build API does is it's your description of the web service. It's going to describe each of the methods or functions that your web service implements, and then the arguments and results that those methods will take. So in this case, let's just take a look at this first method here called list items. And not to get into the details of what this is doing, but basically we have a method that's called list items. It takes an argument called begins with. And so it's going to do a string search for items that begin with the string that you provide. And then it's going to give a result that has 2 levels. The first level is called item list, and then the next level of the result is going to be item name, which is the list of items that match that string search. Okay? So here I'm going to say I give it a namespace reference. It's the service is implemented in the namespace called price check. So I'm going to give it a namespace reference, saws run. 8080 is the port that I'm going to run it on. Now, why am I not running it on port 80? Does anybody know? It's already in use. I happen to run a web server on my machine here as well. And so frequently, in a lot of cases, port 80 is going to be in use, and Conga will nicely tell you that that port is in use. So 8080 is the convention that we use in saws, but really any available port you could use. And then the one here, after the 8080, tells us to run it in a separate thread. So it's going to start up a web server called HTTP serve on that port, and now it's going to handle requests. So we could go out here, so I can use saws.call. Remember, we were using saws.call to call these third-party web services. I can use saws.call to call my own web service that I'm running here. And in this case, the URL or the location is localhost, which is the name that's on your local machine that refers to this machine. You could also give it the IP address, 127.0.0.1, or the IP address of your machine on your network. And all of those would work because they all refer to essentially the same machine. Port 8080, I'm invoking the price check service. I'm invoking the list items method that we looked at before, and begins with empty strings. So that should return, since all strings begin with the empty string, it should return all the items in the database, right? So let's see if, and it does. So we've got apples, balls, cactuses, and daisies. Okay, let's go and take a look at this same service now through our browser. Now remember, we didn't write any HTML, we didn't write any SOAP, we didn't write any WSDL, any workspace description language. We just defined a few simple APL matrices to describe our service. So we'll go out here and look, it knows about the price check web service. And you could click on the service description here, and this is the WSDL that SAWS generates from that description to describe your web service to the rest of the world. Okay? And you can see one of the, let's see. What's that? Well, the WSDL gets generated by SAWS. Okay, you build API to describe your service in terms of some matrices, and then SAWS takes that and generates this workspace description language. And we can look at this part here talks about, we have an operation called list items, and our documentation says it lists the items available via this service. And that was one of the things that we put into that matrix that described the method in our build API function. It takes an input message of list items message in, it sends a message out of list items message out, and then if you skip up here, you can see the list items message in and list items message out. List items message in takes an element which is called list items, and if you look at list items up here, it takes an argument of begins with, and it's a type of string. Has a data type of string. So now if you had to build this WSDL yourself, you'd still be typing, and so would I. And I would probably mess it up. And so SAWS generates all of that for you. So we can invoke the list items method, and remember, we take a parameter of begins with. Well, SAWS has a built-in web server, and it knows how to take that same description that you built of your web service and render it as an HTML page. So you can type in, I want to find everything that begins with a B. And So I get back my item list. Remember, it returned a two-layer result of the item list and then the items in that began with that. So in this case, the only thing in our database that begins with B is ball. But if I gave it a null vector or an empty vector, I'd get everything. So we've built a web service. We can call it from SAWS itself. We can call it from a browser. And this would work with any browser. This happens to be Internet Explorer if you run Firefox or Opera or Safari or Joe's browser. It would work. Now we're going to take a quick look at developing a client from outside of APL that interfaces this web service. Now this is something that somebody who wants to interface with your web service would do. They could, in this case, it happens to be a C# example. It could be Java. It could be Visual Basic. It could be anything else. And so we have a couple of things here. I have a function called compile, which the first thing it does is it runs this thing called WSDL, and it takes the URL where my WSDL is located, my workspace or my web service. I'm going to continue to get confused. WS, for the 30 plus years that I've been doing APL, has always stood for workspace. And now it stands for web service. So please, when I mess that up, forgive me. In the context of SAWS, WS stands for web service, and I'll probably say workspace at least another half dozen times. But anyhow, this is, WSDL is a program that's distributed with, I guess, Visual Studio that takes the WSDL description of your web service and builds a wrapper for it. And then in this case, I'm calling the C# compiler to compile the list items program that I wrote with the price check program that WSDL generated. And we'll take a look at those. Yeah. Yep. So let's take a look at price check first. And you can see that this was auto-generated. And this is what WSDL, the WSDL program, wrote, generated based on the description of our web service. And you can see there's a lot of code here. And I'm not even going to pretend to understand it. So this is a wrapper that can now be compiled with a program you write to access the web service. So there's a program that I wrote called list items. And this is something I can understand. It's pretty simple, and I'm not a C# programmer. So basically what this does is it takes, for anything that you type in on the command line, it buffers it together as a single string. And then it builds a new instance of the price check service. And this came from that pricecheck.cs file that was generated by the WSDL program. And then I invoke the list items method with the command line that I typed in, and I hopefully get back something. If I didn't, we catch an error and display an error message, and otherwise we loop over each thing that was returned in the list and display it to the console. So it's not terribly sophisticated, but it is kind of neat. So I ran it, compiled it, and it built this this list items.exe program. And if I go to C:\APL2, CD. So here's the list items.exe. So if I type list items B, if I type list items B, I get back ball. And if I type list items with the empty vector, which in the command line is nothing. I'll get back everything. Yes?
This one is straight, actually straight on the web example you before, actually put the item name on each of that.
Okay, the reason for that is the HTML interface that's built into SAWS knows how to take the description of that result and render it as a table in HTML. And in this case, I'm just taking each of the things that's returned in the item list and just looping it over and spitting it out to the screen.
So that what the HTML representation is something visual to understand which the name of the item or what the name of the column.
What's returned there is, oh, I see what you're saying.
When you see in the workspace, you see like a lot of the reference around the actual data.
Right.
This is just returning the data, so I'm just wondering where that is the reference, what's telling you what the data is versus the actual data. This is all just getting back to the actual data and the list.
Right.
And then everything else shows all the reference information around the item name, item list.
Right. The SAWS will return a structure a nested structure that can be used. When you work directly off the WSDL, what WSDL took out of this was just the strings that are returned by the web service, right? It didn't use the structure. One of the things that SAWS comes with is a tracing facility. So you can turn trace on and then look at, for instance, we'll execute the get item info method on apples. And you'll see that it spits out a bunch of other information here. And this is a way that you can look at the message that SAWS is producing and compare it. If you're calling, this is particularly useful if you're calling a third-party web service. You can see the message that saws.call is producing and compare it to the sample. If we were to go back to our weather web service here, you could compare it to this sample message and make sure that the message that saws.call is producing matches this. Web services are very particular about punctuation and capitalization. It's significant. I mean, in most cases on a URL, capitalization is not significant. In web services, it is. And some web services, in particular, well, some of them will use a trailing slash, some will use a leading slash, and you need to make sure that the message that you're producing, that you're passing through saws.call, is the same as their sample. So saws.trace will tell you, here's the HTTP header that I'm sending, and here's the request itself, which is a long character vector, and then we also show you the XML, the formatted XML representation of that request. Oh, now I've done it. And to shut down saws, you use saws.stop. You can run multiple web services at a time. So you could have, there are a couple of different ways to do that. One is you can start up multiple saws servers. And the other way, remember when we invoked saws before, we gave it a left-hand argument of a namespace reference to the price check namespace. And in this case, we're not giving it any namespace reference, we're just running saws.run. And what this does is, saws is smart enough to look at the namespaces in your workspace, and if something matches a request that comes in, and that namespace implements a web service, it will invoke that web service. So we can go out to our browser here, And I can go to http://localhost:8080/ my web service, okay. Well, that one wasn't found. But this is a web service that's sitting out there in the workspace. If we look at the Workspace Explorer, we'll see there's a namespace called My Web Service that implements two methods. And I can go to, and you can nest namespaces, right? It will follow. So I can go to, I have a namespace in the workspace called Web Services, and I have inside of that a weather namespace that implements a simple what should I wear service. So I click on what should I wear, I give it a zip code, I'll give it my home zip code again, and it takes a look at, it goes out, it accesses another web service, gets the current temperature, and then based on that temperature, suggests something you should wear. So in this case, the maximum temperature is 72, so I should wear a sweater. Although 72 is a little warm for a sweater. I might need to rethink that logic. Okay. Now, the next thing I want to talk about, and let's do one other thing before we get into legacy code. Let's take a look at that HTML page that's produced when you bring up your web service. That's actually, you can customize the look and feel of that. And there's a thing here called style, which is a cascading style sheet. So if you know CSS, you can modify this and change the look and feel of what that web service or what that web page looks like. Okay, let's say you want to put a web service interface to your legacy application. Well, I have a legacy workspace here, and all legacy workspaces have to have a function called foo. And foo does something exceptionally clever. It adds A and B, right? So, and then a lot of us have maintained other people's APL code, and don't you love it when somebody has to repeat the obvious, right? So it's R gets A plus B, add A to B giving R. It sounds kind of COBOL-ish, I'm sorry. But I just love it when people, produce overly obvious comments. So the only things you need to do to interface to legacy code
What is your definition of legacy code?
an APL application that already exists. How's that? So you can copy the SAWS namespace into your workspace. And SAWS is completely self-contained. It includes all of the code necessary to run. It includes Conga. It includes all of the SOAP and WSDL processing code. And if possible, I like to create an API namespace for my application. And then write functions to interface to your legacy code. And then write the build API function to interface to your application. So if we go back to the workspace here, and where's my Explorer? There it is. So I wrote my legacy API namespace, and my build API function describes my web service. And I have one method called foo, and it calls the legacy function foo. It takes a left and a right argument It takes exactly one, a minimum of one, a maximum of one, so it takes exactly one left argument, and it's a data type of double. It takes exactly one right argument, and it's a data type of double. And then it produces exactly one answer, which is a data type of double. And so in these few lines, I was able to describe that legacy, the interface to that legacy code. And then I have to write the method foo, which the first thing, I defined two little functions here. One to pull out information from the arguments, or the argument markup language structure that I get, and then something to convert them to a number. So my left argument is I do a to_num of get element left, and my right argument is I do a to_num of get argument right. And then all I do is call foo, my legacy function, with those left and right arguments. And then I get the result back, and then I return a structure that it was described in my, that was described by my build API. So it returns a thing called answer, and it's the data that was returned by the foo function. So, and we can call so I can go out to localhost. I give it port 8081 this time. And I can give it, I don't know, 4.5 and 123. And if I do it right, it should add up to 127.5. So that's as easy as it is to build something, to build a web service interface to your legacy code. Now, of course, not, yes?
You showed a test function earlier to the channel.
Yes.
Is there anything in the workplace report on port usage?
There are reports on port usage.
Yes.
No. But you could take a look at the servers that are running. I think it's possible, and Bjorn can correct me if I'm lying about this, but you can look at the servers that are running in Conga, and is one of the properties of the server the port that it's running on?
I think you can get it back. If you have started the server, you will know which port you have started on.
Yeah. Yeah, the answer is keep track of the ports when you start the servers.
But you can also try the ports, can't you? You see if they're available.
Yeah, I mean, you could try and use the port again, right? But you don't know whether it's you or something else that's got it.
You'd almost have to have a thing at the beginning of the workspace, say try this report, then do it again there, the differences are.
Yeah.
Ones that have started since, they may not be able to use that.
Right. So when you're building web services, there's some things to consider. One is a lot of web services use some sort of user authentication and authorization. You may want to publish a web service that's available to everybody, or particularly if you want to sell subscriptions to your web service, you want to be able to control who has access to it and be able to track their usage. Web services are stateless, which means that each invocation of the web service is independent of other invocations. So there's no concept of state. So for instance, if you log in, if you present some login credentials in one call to your web service, unless you take some other steps, the next invocation of your web service, let's say it's a different method, won't remember those login credentials. Now there's some ways to get around that, and there are also ways that we are looking at implementing in SAWS to help accommodate that. But at this point, each transaction is stateless and has no concept of anything that went before or will come after. Another thing is third-party web service availability and reliability, particularly the free web services that are out there. Those web service providers are under no obligation no service level agreement to provide the same web service tomorrow that they did today to make sure that it's available. And indeed, one of the web services that I use, that I was hoping to demonstrate today, I can't get to because their server's too busy. And then if you're looking at rolling out web services in some sort of a production environment, you're going to want to look at load balancing. And some of the work that we're doing with SAWS for one of our clients is to look precisely at that, is some schemes on how to do load balancing so that you're not, so that you have a way to handle larger and larger user loads. Of course, the answer is just get a bigger machine, right? Now, SAWS, the evolution of SAWS, it was kind of a proof of concept in the 2008-2009 frame. At this point, we were able to provide and consume web services and demonstrate that. Right now, it's a useful tool. The code is pretty stable, it does some useful things, and we have people that are actually using it to do real things. As I said, the code is stable, we've got some enhanced functionality, and then what we're looking at into 2011 is really turning this into a production quality tool, where we'll have error logging, we'll have usage logging, we'll have a management console so that when you fire up a SAWS web server, you can manage it remotely through some sort of a web browser interface. We're going to look at being able to define web services in an object-oriented fashion. Rather than using build API to build these APL matrices, we want to be able to describe web services, more complex web services. And once we start doing that, we go beyond what we can accomplish through that simple matrix-based format. So we're looking at doing an object-oriented interface to it. And then there's these web service specifications. Has anybody heard of web service specifications before? Well, neither had I. And so if you look at web service specifications, there are all of these web service standards. Most of them begin with WS-something. And there are all these different ones for security, for data exchange, for messaging, for privacy, reliable messaging, resource specifications. There's a whole slew of them. And we are looking at a strategic subset of those to implement, primarily at the request of a customer that needs them. But one of the things that we will be doing as we move into that more object-oriented version of SAWS is it should be possible to support most of these web service specifications. And if we don't do it, the code is open and you're welcome to do it yourself. So, are there any questions? No.
Forgive me, I was late. What was the definition of we?
Who we?
Yeah, you were telling us that we will do this or that. Explain when I was
At this point, I'm the primary developer of SAWS under the auspices of what Dialog wants me to do with it. But for instance, one of the components within SAWS is Conga. And so I have to leave that in the very capable hands of Bjorn. And so there's some collaborative effort in building out the functionality of SAWS. Yes? The SSL connection is in Conga, and corresponding to saws.run, there's a saws.run secure that you give it a path, a certification or certificate path, and it'll run using SSL on port 443 by default.
Could Conga be running in order to use the web service, or?
Yes, well, Conga, when you initialize, there's a saws.init function, right, and it fires up, it initializes Conga. So, and Conga is built into SAWS. So when you copy in your SAWS namespace, you get Conga, comes along for the ride. It'll work in Windows, Linux, AIX, any place where Dialog APL version 12.1 will work. And so, you know, if there are any other questions, ask away. If I know the answer, I'll tell you. And if I don't know the answer, I'll make something up that sounds really convincing. So, okay. So, in the time that's remaining, your task or challenge or assignment or something to do with the time that's left is to build a web service using saws. Is everybody up to the challenge? Okay. And you know, some ideas are to build a simple service that requires valid logging credentials, or to build a service that calls another service as a part of its processing. And if you take a look at hash.webservices.weather, you'll see an example of a web service that does that. And that's the end of the slideshow.
Can you show the example of the sauce called the weather on the story on it?
Sure. Which weather?
So WS.cdon.com?
Sure. Let's see. The easiest way to do that may just be to. Okay, so it's ws.cdyn.com, port 80. Actually, yeah, it's up here as well. Weather, WS, where weather is capitalized and WS is capitalized. Okay.
Right now, I was putting the weather WS slash and the name of that.
Oh, okay, yeah. Now, for instance, let's say you wanted to use this CDyn weather web service as the basis for your web service, right? What would you do if somebody types in an invalid zip code? So you could take a look at it. Let's do a zip code of zeros. And so one of the things that it returns as a part of its result is the success element has a value of false. And it's also got a response text that says the city couldn't be found. So that's something that you could look for in the result that you get back from the web service. So any other questions? Anybody trying to build a web service? What's that? Yeah, let's, I can show you a good example of that. So my XML here is in the 22 pick of ZZ. So that's, actually it's column 3 of that. So I'll just call it XML gets disclose 3 squad 2. So XML looks like that. It's an XML string. And what quad XML does is it turns that into a 5-column array. The first column is a level, so it indicates the level of nesting in the XML. The second column is the element name, or the tag name. The third column, and if we were to display that, it might make it a little more obvious. The third column is the value of that tag. And then the fourth column is a list of attribute value pairs. So if your tag has attributes, it'll list those there. And finally, the fifth column is some powers of two thing that tells you something about what that, what the content of that tag or what the content of that row is. And I don't remember all of the different ones. There are ones that say this is an element, or it's a child, or it's an element with children, or there's a whole bunch of.
That one I would say, if you're interested in that, download the latest 12.1 documentation. Which one was it downloaded? Which one did you ask me to do?
Yes,
Yes. Is it the language, the user guide with language reference?
I think it's in the language
So
reference.
download the latest 12.1 language reference from our website, because Brian pointed out about a couple of weeks ago that we actually forgot to actually put details of column 5 in the existing manual. If you download the latest one, it has the information in it. The other thing is that for XML, if you hand it an invalid XML document, it will fail. It is not designed to be an XML
Parser, or processor.
It's not an XML processor. It does not check for good XML. That there are better tools in the world for. It is assumed that XML code is valid XML.
We need the XML declaration.
Yeah. I mean, yes, just to make sure it's well formed. Yeah.
So if you don't have that, it'll fail it. I mean, if you give it an XML.
It will fail. I wouldn't want to rely on the results if you hand it in valid markup.
But it won't crash.
It might.
Oops, it's not in the language reference.
So
It should not. I mean, the answer is it should. Yeah. I mean, if
it's
you
not
manage to,
expected. It's expected not to.
if you get rubbish out, that's your problem. If it crashes APL, that's our problem. We'd like to know about it. We'd ask for a. You should get a domain error just to say that it can't cope.
So one of the neat things, and something I mentioned a little earlier, is that Quad XML also takes one of these matrices and turns it back into an XML string. So if I do the Quad XML of the Quad XML, it'll turn it back into a formatted XML string. So it's also a nice way of tidying up your XML. I'm sorry?
XSD validation capabilities, so if you hand in an XML and XSD.
Oh, you mean namespace qualification and?
Yeah, I think it was
Funny you should mention that. That's something I'm going to be talking with the some of the dialogue folks about, because one of the things we do a lot of in SOAP is processing namespaces. Particularly if you want to do some analysis on like the WSDL, and you want to be able to get down to the actual schema of the, if you want to do data type validations for custom data types and stuff like that, being able to walk the namespace is, right now I'm doing it the hard way. And I'm trying to figure out a way to have dialogue make it easier for me.
Having Richard Smith's probably a good start.
Yes.
bad web service if you go and fix one argument called data that maps to XML and data.
Oh, yeah.
XML and it's just a data stream.
Yeah.
So I'm missing just come in at that whole XML and make things like that.
Well, I'm not sure if we can make it run here. I haven't had much luck so far from Germany. I'm not sure whether this particular web service vendor filters out IP addresses that aren't like from the US. It might, but we'll see if we can do this. Z gets quad new. This is one of the samples that's in the SAWS workspace. And nope, can't retrieve. You can't retrieve the country city. I still have saws.trace on, which is why we got that. But if we look at, bring up the Explorer, and we look at client sample, and I wrote a little class called www.weather, which is really cool if you can get it to run. It produces a list of countries, and then you pick a country, and then it gives you a list of cities within those countries. You click on one of the cities, and it gives you the current weather there. And it gives you all kinds of stuff about temperature and relative humidity and wind speed and direction, and so it's pretty neat. But one of the things that I had to do was for instance, to get the list of cities, the first thing I do is I call the get cities by country method for all countries, and it gives me this lots of XML. So I convert the XML into an array. I look for all the tags that are called country, and then I look for the city names that follow the countries and country entries. And so I'm doing a lot of machinations with the XML. Some web services are really good about describing the results in some sort of structure. Others say, I'm just going to give you back an XML string and you're on your own.
Brian?
Yeah.
One of the parts that you're working on right now, you're going to send an input output from APL to the C#-based program, and in a small format, the top line, a similar version number followed by the UTF code.
Right.
How does the UTF code define? Because I know there are versions of it, and I think if you can write your XML from APL, does it put that UTF code in the top?
I think, and this is one of those answers that if I'm going to try not to make up something that sounds really convincing, and I'm trying to give you the right answer. And I believe that it's hard-coded into SAWs, and that's one of the things as we move to the more object-oriented version, is I want to make some of those things parametric. Hello. Is that rain?
Some kind of tin roof.
Oh, okay. Interesting. So, yeah, there are a number of things that right now are, as we move from the proof of concept to the current stage of SAWs, there are some things that are hard-coded into the SOAP messages that we produce in terms of the tag names that we use for the SOAP envelope and so on, and what we name the namespace references and so on. And I want to make those more parametric, particularly in the SAWs call side, because there are some things, there are some web services that are kind of particular about that. Some don't care, it seems.
So going forward, would you look at the output compiler from the machine and would you input that information in the header?
Yeah. Yeah, there's stuff right now that's hard-coded into the header. Well, actually, the header element, one of the specific things that we're doing with SAWs is to make the SOAP header element accessible to you, both for processing requests and for defining web services, because a lot of those WS specifications for like WIS addressing, WIS security, WIS reliable messaging, they all use the header element to implement their functionality, and so I'm going to have to expose that to the user.
So right now, you're going to hardcoded header on the top of the matrix that comes out, the XML matrix. Would that be able to make any changes when the conversion comes out, or?
I'm not even sure that we include a header element in the SOAP message, do we? No, I think we just use yeah, right now we just produce an envelope and a body. We're not even including a header tag or a header element.
It would change and you would have a header.
Yeah, yeah.
So if you're creating something right now that doesn't have header, and you're hardcoding the header.
Oh no, you don't want, well, yeah, don't do that. don't hard code header. Wait, you know, a few weeks, and when I make the header available to you. So, yeah, well, that's one of the reasons that we want to move to the more object-oriented version, because it just makes it a lot easier. We're limited in how much we can describe using those, the matrix description. So, any other questions? Yes?
There's not doing an example here, I tried to call hit domain error, and I corrected that, and now I started hitting the value error, I reset the workspace. So there's some error.
Oh, yeah.
When you start off with saws in it.
There are a couple things that you want to do. One is, if you are you running saws.run
I was using saws.run.
and you were getting a value error?
Yeah. Well, first I did domain error, but I had the.
Okay, yeah, do hash.saws.init, and that kind
Yeah,
of,
and reset. So yeah, so I guess the value error again, is not just a value error. I guess it's basically a web workspace on the web, when it did the domain error.
shouldn't have. Tell you what, I'll take a look at it.
I didn't know if it.
Yeah, no, we can, so, wow, we finished early. Anybody else? Any other questions? Yes?
I have a problem when I try to test thing, I get a winsock error, and when I look this error number, it's some kind of family of the port that is not matching, so I'm quite confused.
If it's a WinSock error,
What error number is it?
It is 100 and then 47.
47?
1047.
Is that port in
I
use?
think it's you have used the port number for something else.
I also tried to change the port number, and it was still the same.
Excellent.
Yeah, one of the other things is that if you, go ahead.
Oh, it says it's the wrong.
Uh-huh. If you turn saws.trace on, not only will it trace any saws.call executions, it'll also trace any requests that come in through saws.run. And in the latest version of saws that's a little bit newer than what you have on your memory sticks, we've added some debugging options so that you can capture the last request and response that came into the server or that you sent with saws.call, so that you can examine those to see how things are.
Thanks, Ryan.
Thank you.